In this last video for quadratic functions, we're going to solve some applications. Quadratic functions model real-life situations that occur in science, business, engineering, and other areas. These models are helpful when a variable needs to be maximized or minimized. And why is that? Well, when we think about the maximum or minimum point on the graph of a parabola, it occurs at the vertex. So those are pretty easy points to find. So our applications, when it asks for the maximum or minimum, always think about the vertex in that particular case. One of the applications we'll look at involves projectile motion and free-falling objects. And there is a model that we can use. It's called the height of a projectile. And it is written as S of t equals negative 16t squared plus v sub 0 t plus s sub 0, where t is time in seconds, s sub 0 is the initial height in feet of the object, and v sub 0 is the initial velocity in feet per second. Example 4 states that a baseball is hit straight up with an initial velocity of 80 feet per second and leaves the bat with an initial height of 3.5 feet. Its height h in feet after t seconds is given by the equation h of t equals negative 16t squared plus 80t plus 3.5. So notice that the initial height is 3.5, which was that constant term. The initial velocity of 80 is that coefficient of t. And we want to find how high is a ball after 1 second. Find the maximum height of the ball to 1 decimal place. When does the ball reach its maximum height? And when does a ball hit the ground? To find the height of the ball after 1 second, we know the time, we know t, we don't know the height h. This is equivalent to just finding h of 1, which is equal to negative 16 times 1 squared plus 80 times 1 plus 3.5. And this gives us negative 16 times 1, or negative 16, plus 80 plus 3.5. And we get 67.5. So in 1 second, the ball is 67.5 feet above the ground. Now part B and C really have to go hand in hand. We're asked to find the maximum height of the ball to 1 decimal place and when the ball reaches its maximum height. Now the maximum height is going to be the y value of the vertex. And the time it takes to reach that is the x value of the vertex. I'm using x and y. This problem uses t and h, but hopefully you understand what I mean. So we have to do b and c really together. So I actually need to find the answer to part C first. So we'll just write that this is b and c. The x value of the vertex, which is the t value in this case, is going to be equal to negative b over 2a, which is equal to the opposite of 80, right, the coefficient of t, divided by 2 times negative 16. So that is negative 80 divided by negative 32. And you can use your calculator to find that that is 2.5. Now this is the time, so 2.5 is in seconds. So it's going to take 2.5 seconds for the ball to get to its maximum height. That's actually the answer to part C. Part B then is what is the y value when the input is 2.5. So that is, we want to find h of 2.5. And this gives us negative 16 times 2.5 squared plus 80 times 2.5 plus 3.5. And you can simplify that on the calculator and get that's 103.5. So this means that the maximum height of the ball is 103.5 feet. So max height is a y value of the vertex again. At what time does that occur? And that is at the x value of the vertex. And then when does a ball hit the ground? Well, it hits the ground when the height is 0. So we have to solve this equation. To answer part D, we have to set our function negative 16t squared plus 80t plus 3.5 equal to 0. So we could multiply through by -1 to get rid of the negative on the square term to get 16t squared minus 80t minus 3.5 is equal to 0. So we get A is equal to 16, B is equal to negative 80, and C is equal to negative 3.5. To solve this quadratic equation, I would suggest that we use a quadratic formula. We don't have x, we have t is equal to, let's restate this. Hopefully you can recall this by heart. The opposite of b plus or minus the square root of b squared minus 4ac, all divided by 2a. Substituting the appropriate values of a, b, and c, we get the opposite of negative 80 plus or minus the square root, and then there's a b again, so put that in parentheses, negative 80 squared, minus 4 times a is 16, and c is negative 3.5, and then this is all divided by 2 times 16. So let's simplify this just a bit before we go to our calculator. And we'll probably need our calculator to even do this, but we would have the opposite of negative 80 is 80, plus or minus the square root. Let's figure out what this number on the inside is. So if I enter in parentheses negative 80, close parentheses, squared, minus 4 times 16 times negative 3.5, I'm going to get 6,624 on the inside of the square root, and that's divided by 32. So we actually have t is equal to 80 plus the square root of 6,624 divided by 32, or t is 80 minus the square root of 6,624, all divided by 32. So using our calculator, we can approximate these. Be careful here, I need to put in parentheses 80 plus the square root of 6,624, exit the radical, close the parentheses, divided by 32. And I get t is approximately 5.04. I can repeat this expression except change the plus to minus, so I have parentheses 80 minus the square root of 6,624, exit the radical, close parentheses, divided by 32, and I get t is approximately negative 0.04. And so when does a ball hit the ground? Well, it can't hit the ground at a negative time, so we have to discard the negative solution. This means that it will hit the ground in approximately 5 seconds after it was hit. Example 5 gives us a sheet of cardboard 10 inches by 12 inches will be made into a box by cutting equal-sized squares from each corner and folding up the 4 edges. If the area of the base is to be 80 square inches, then what size squares should be cut from each corner? So we have a diagram on the screen that shows that we have this piece of cardboard, a rectangular shape, that has a length and width of 10 inches and 12 inches. And we're cutting out a corner a square right from each corner, and we don't know the dimensions of that square. So we have a square that we're cutting out of each corner, and I'm labeling it x on each side, right? Because the square is the same length on all four sides. And so I need to figure out what is the area of this resulting base going to be. And so the area of this base is going to be the length times width of this new box that I'm forming. So I have to think about what is the length and width of the box after these corners are removed. And if I take out x from each side, what was originally 10 inches long is now going to be reduced by x 2 times. So that is, it's 10 minus 2x. And likewise, if I had a box that was 12 inches wide and I reduce it by x on each side, I'm reducing it by x 2 times, so 12 minus 2x. And I know that the area of the base is to be 80 square inches, and so my length times width of this box is going to be 10 minus 2x times 12 minus 2x, and that's equal to 80. And understand that I could write this, and if we think about in terms of quadratic functions, a formula for the area of the box, a of x is equal to 10 minus 2x times 12 minus 2x, and then I'm setting that equal to 80. So here I would have to solve this equation by first multiplying the left side. I would get 120 minus 20x minus 24x plus 4x squared is equal to 80 after I distribute. Then I need to combine like terms and set one side equal to 0. So in standard form, I would write this as 4x squared. Negative 20x minus 24x is minus 44x. Notice here I have a plus 120, but I will need to subtract the 80 to set it equal to 0. So that will be plus 40 equals 0. To solve this equation, I would first realize that I have a common factor of 4 that I can divide through to get just x squared minus 11x plus 10 is equal to 0. And I can try to see if this factors. Are there factors of 10 whose sum is 11? And there are. Therefore, this would factor as x minus 10 times x minus 1. So I get that either x minus 10 is equal to 0 or x minus 1 is equal to 0. So x is equal to 10 or x is equal to 1. And you might think, oh, 10 and 1, there's two answers, but there's actually not. If I plug in the 10, I would get a negative value for the resulting size of the box, right? 10 minus 2 times 10 is 10 minus 20 or negative 10, so that does not work in this context. So that means that I need to remove a square of size 1 inch from each corner. Example 6 is the heart rate of an athlete while weight training is recorded for 5 minutes. The function f of x equals negative 8.7857 x squared plus 35.2429x plus 84.2286 models the athlete's heart rate for the domain of 0 to 5. During this exercise, what is the maximum heart rate of the athlete? So notice that we have a quadratic function given. The coefficient of a is negative, which means that the parabola would open down, so the maximum value will occur at the vertex. We want to find the maximum heart rate, which means we need to find the y value of the vertex. So the y value of the vertex, to find that, we first need to find the x value. So x is equal to negative b divided by 2a, which is the opposite of 35.2429 divided by 2 times negative 8.7857. And when we use our calculator, we would find that this is approximately 2.006. And then to find the y value, we find f of 2.006. And this is going to be a lot of numbers to write out. We have negative 8.7857 times 2.006 squared plus 35.2429 times 2.006 plus 84.2286. And we can use our calculator to find this value, and we get this is equal to 119.572. So what is the maximum heart rate of the athlete? So almost 120 would be the maximum heart rate. And when did it occur? It occurred about 2 minutes after starting the weight training. And then the last example, a diver is standing on a platform 24 feet above the pool. She jumps from the platform with an initial velocity of 8 feet per second. Use a formula h of t, which is equal to negative 16t squared plus v times t plus s, where h is her height above the water, t is the time in seconds, v is her starting upward velocity, and s is her starting height. How long will it take for her to hit the water? So first of all, we want to write our function h of t, which is equal to negative 16t squared, plus our initial velocity was 8 feet per second, so this is going to be plus 8t, plus her initial height is 24 feet above the pool, which is 24. So when we're asked to find how long will it take for her to hit the water, well, the water is going to be 0 feet. That is pool level, basically, so we want to find when the height is at 0. So we'll set negative 16t squared plus 8t plus 24 equal to 0. So again, notice that this one didn't say maximum or minimum, so we're just setting our function equal to this number. And if you want to reduce this equation, there's a common factor of negative 8. So we could get a positive 2 squared minus t minus 3 is equal to 0. And we could see if this factors. You could also use quadratic formula if you wanted to. The factors of 2t squared are 2t and t. And the factors of 3 are just 1 and 3, and I need to somehow get a negative 1 in the middle. So I'm going to put the 3 first and then the 1 second. So notice my outer product would be 2t. My inner product would be 3t, and those do have a difference of 1. We need to get a negative 1, in fact, so we're going to put the negative on the 3 and a plus on the 1. So we have 2t minus 3 equals 0, or t plus 1 is equal to 0. So we add 3 to get 2t equals 3, or t is 3/2, or t is equal to negative 1. Again, we can't have a negative value for the time, so this means that in 1.5 seconds, the diver will hit the water.